circulation, which is the circulation between the heart and the rest of the body. And then the pulmonary circulation, which is the circulation between the heart and the lungs. So systemic circulation, remember, between the heart and the body, basically goes to the left side. It's going to go in the left atrium, left ventricle, pumped out of your body through the arteries, capillaries. Remember, we learned those last time. And back through the capillaries, to the venules, the veins, and back into the right atrium of the heart. And I know we're going a little fast, but we do have an activity, and it's going to sink in then. Okay, pulmonary circulation. Pulmonary circulation goes from the right ventricle, the right atrium to the right ventricle, up through the pulmonary artery to the lungs, the pulmonary veins, and back to the heart. The difference between the pulmonary circulation and the systemic circulation is basically these arteries in the pulmonary don't have oxygen, and the veins have oxygen. In the systemic system, the arteries have the oxygenated blood, and the veins have the deoxygenated blood. Now, we're going to break up into groups of 3. So why don't you 3? Freddie, you want to slide over here? And 3. I have a little activity. You're kind of puzzled. We're going to reconstruct the circulatory system. And I've got these little green cards in here, and these are labels, so we're going to label them too. If you have any questions at any time, please raise your hand, and I'll be walking around to see if you guys kind of understand what's going on. These pieces are the blood, these are the carbohydrate blood vessels. So these are the ones that don't have oxygen in them. The red ones are the oxygenated blood vessels. And the capillaries, they printed off a little funny, so if you're not sure what color they are, I wrote the color on the back. Does anybody have any questions right now? That is the liver.
Is that helpful?
Yes, it is. Yeah, you might want to do it long way on the table because they're
Oh, this is supposed to be red.
pretty much. It's the land here. Yeah.
So
The ones, it's just because it's hooked. It fits there better.
oh, these are
So long as they're,
capillaries are on either side. I know, that's cool.
I think.
Look at this
So
one.
I'll it's down.
And this is deoxygenated.
Oh, yes.
And where is it coming from?
So switch it back.
Yeah.
Same with these.
How do we want
Just think of it like this.
I'm doing wrong.
It's not gonna, if it's traveling to
You
the
did it
lungs,
great.
it's
You did it great.
oxygen, so it's coming back to the lungs to pick up more
All
oxygen.
right, well, some of these are easy.
No, it's not pulmonary.
I know.
That works better. Just because it's cooked and it fits better.
Oh, I had that so nice little ball out.
The
These come out of
blues,
these two,
the
right?
blues have carbon dioxide.
Yeah.
So it doesn't matter, like this is gonna fit better.
Yeah.
Because it's coming back to the
Yes.
market.
And it's coming from the body into the radiator. And then it's gonna go to the ventricle and it's gonna come to the lungs.
Oxygen.
It's gonna come out of the, it's
Yeah.
gonna come out of the aorta. This is the aorta that comes out of the ventricles.
Yeah.
This is kind of hard because it's
And the meeting
comes
came
up
out, I
on
think
here.
maybe this one,
Oh, that's.
It's really gonna
or this one, I don't know.
no, it comes out of
I don't remember this one.
Back, gentlemen.
It's a little tricky to see. It's a little tricky to see.
Yeah, well, I would say it's like the aurora, except it's, so you
Right,
guys.
the ventricles, they, right by the disease,
I got it top there. I don't know. Sure. There's always a picture of it. Sure knows.
That sounds like wine.
I didn't want to say anything, guys. Didn't want to correct us.
one side, and then what goes to the other, I think.
Yeah, that's good. This. These. The heart on the right side
Okay.
is come back from the body, and all the oxygen's on its back.
That's usually the ones to get the oxygen.
Like, no, the eggs.
See that?
Yeah, they work well because,
It doesn't, the color doesn't matter.
you know,
The
besides like
color
on the
is-
battlefield,
red is
like
oxygenated,
learning
it's
how to
oxygen.
sew things up.
Blue is
Well,
carbon.
think about how,
But
with bacteria.
Because
Yeah, well, I mean, a lot of that is microscopes, I think.
Yeah.
Because, okay, this is the blood coming from the body, and all the oxygen is already used up, and it comes into the heart. And then, the difference from this picture is that that heart actually is kind of crisscrossed, but this picture does it this way just to show you in more of a linear fashion, so it's more visible to you that it goes up. So then this goes to the lungs where it's gonna pick up the oxygen and come. Make sense?
So I have to go to the cardiologist once a year. I have a mitral valve. Efficiency. So like, it's backwards. So it doesn't come back efficiently, so it only squirts some of that.
All right, so we're gonna wrap up this activity. And if you wanna get back to your original spots real quick,
maybe,
we're gonna move on. Does anybody have any guesses what this could possibly be?
It's a radio signal.
Kind of.
Station.
Like the volume of the blood going through?
No, it's a heart.
What?
It's a heart. It's a 4-chamber heart. It's a fish heart. Yeah. Okay, there's. Why does this heart look different? Does anybody have any ideas? Hannah?
Well, it's kind of longer than kind of like all together.
Okay, yep. And why do you suppose that is? Think of the differences between a fish and a mammal, the heart that we just did. Why would you think that it would be different? Think of the function of the heart and what it does. And the circulatory system. What does the circulatory system do? What's the main function? To move the blood. What does the blood do?
Carry oxygen.
Carries oxygen, right. So where does the mammal get its oxygen from? The air from its lungs, yes. And how does the fish get its oxygen? Gills, that's right. That's why this heart is different, because it functions different. The gills get the oxygen differently than the lungs. And in a fish, it's just one continuous motion. One thing I want you to notice is, notice this kind of goes in the V, and these two are kind of the same. This kind of goes in, this is real skinny. What do you think that shape would do to the function of these different sections? Does anybody have a clue or a guess? Jeff?
Creates pressure.
Creates pressure. What do you think these two would do? This creates pressure, so it probably pushes it through. What do you think that these two would do, since it kind of funnels in? It's more geared to the
Collection.
collection. Exactly. All right, here's another one for you. Does anybody notice the difference between this heart and the mammal heart that we did? Whoa, no. There we go. We're back. Three chambers.
That worked, Vicky.
That's right. And why do you think this has 3 chambers and the mammal has 4 when we both breathe oxygen through lungs?
Cold-blooded versus warm-blooded?
Think about timelines.
No, more primitive.
And yes, more primitive evolutionary scale. Okay, I want to leave you with one last thing. This is our exit activity. We're gonna listen to a song. Yes. This song, choose a verse.
Alright, this tune is called Pump You. 1, 2, 1, 2, 3.
Pumps your blood. The right atrium's where the process begins, where the CO2 blood enters the heart. Through the tricuspid valve to the right ventricle, pulmonary artery and lungs. Once inside the lungs, it dumps its carbon dioxide and picks up its oxygen supply. Then it's back to the heart, through the pulmonary vein, through the atrium and left ventricle. Pumps your blood. The aortic valves where the blood leaves the heart and it's channeled to the rest of the body. The arteries, arterioles, and capillaries to bring the oxygenated blood to the cells. Tissues in the cells feed off waste and CO2, which is carried to the venules and the veins. To the large vena cava, to the atrium and lungs, and we're back to where we started in the heart.
Okay, on your exit chart, I want you to choose a verse.